Good morning children, how are you? Welcome to our 7th class science. We are in the last session of our first lesson in the discussion. It is about acids and bases. Okay, what are acids? What will be its taste? What are bases? What is its taste? All the things were discussed. Acids will be sour to taste. They show the property of corrosion, right? And bases will be bitter in taste and they show soapy nature. They will be slippery. And we also see different indicators like universal indicator, blue litmus, red litmus, methyl orange, phenolphthalein, so many indicators. And their color changes also in respective solutions. Like in acids they show one color, in bases they show one color. Like that all the indicators effects will also see. Okay. Now in this session it is about different concepts regarding the relation between acids and bases. When we add them both together, what changes do we see? Let us see now. First topic is making an acidic solution into basic. I am using two colors because generally in any indicators acids finally they show red color. You see blue litmus turns into red, right? Methyl orange also turns into red. And bases will be generally bluish in color in the indicator effect, right? That's why I am using both. Now, how to convert an acidic solution into basic? Here, for these activities, we take two solutions. One is HCl, stands for hydrochloric acid. It's present in our stomach also. I mentioned one very important point here. The acid in our stomach is so powerful that when we bring a blade towards it and when the acid is falling down, then the blade will cut into pieces. That is the power of the stomach acid. And NaOH, sodium hydroxide, in general it's called caustic soda. Okay, now what we shall do? See here, first let us take some acid drops. Okay, and let us take few drops of HCl, hydrochloric acid. Just be careful, it should not be in contact with your fingers. Then add any indicator. Here in the textbook it is mentioned with phenolphthalein indicator, but you can use any indicator, either phenolphthalein or methyl orange. Phenolphthalein has actually no color. It will be colorless in acidic solutions. So when after taking little amount of acid, if you go on adding phenolphthalein, still it shows no color. Now what shall we do? We add some solution of sodium hydroxide drop by drop. So when you go on adding sodium hydroxide, slowly that colorless becomes into some color. What color? Pink color, because phenolphthalein shows pink color in bases, right? Now when you go on adding even more quantity of sodium hydroxide, that means when sodium hydroxide quantity exceeds hydrochloric acid quantity, the pinkness becomes more and more. That means the acidic solution became now basic solution due to more quantity of base addition. The same way, if you do in the reverse process, we can turn a basic solution into acidic. What we do? First take some drops of sodium hydroxide solution, then add phenolphthalein. It shows pink color. Okay. Then now drop by drop add acids, HCl acid drops. Then slowly the darkness in the pink color becomes lighter. Then slowly the pinkishness disappears and it becomes colorless. Colorless shows it became acidic. So initially it was basic. Now it turned into acidic because we have taken less quantity of base and more quantity of acid. Right? Now let us see what happens if we take both solutions in equal quantity. That means equal quantity of acid and equal quantity of base. When both of them added together, acid and base, they form salt and water. This reaction is called neutralization. That means the product formed in this reaction will be neutral. It's not acidic, not basic. So here we are adding hydrochloric acid with sodium hydroxide solution. We are now preparing a neutral solution. Here, when the reaction takes place between hydrochloric acid and sodium hydroxide, a salt is formed that's called sodium chloride along with water. Okay, the most important thing here is the quantity of acid and base should be taken in equal. Otherwise, any of the above reactions may be happening. Right? So, the process in which acid reacts with the base to form salt and water is called neutralization. One very important point is that all neutral solutions are not salts. Okay, there are some differences. The salt is the one which is formed as a result of the reaction between an acid and base, whereas some solutions which do not have the properties of either acid or bases, something like sugar and starch solution, they are neutral solutions. Even distilled water, what we generally use in the batteries, it is also a neutral solution. A solution which does not have any charges is actually called a neutral solution. As I told, a salt is a substance which is formed in the neutralization reaction which is taken between acid and base. Okay, that is the difference between a neutral solution and a salt. And also we have a little information about manures. In the present situation, so many things are getting polluted. The food is also now becoming very deadly, not pure to eat, because we are using so many chemical fertilizers which are degrading the quality of the food. That's why now the world is turning towards organic farming. The organic items what we use for cultivations are so-called manures. They are natural. They do not have any chemicals in them. So now that will be in the process. Nowadays that is growing up. It's good sign. So it's better to use all the organic substances for farming. So those are called manures. Now salt we have discussed here. How many types of salts we have? We have majorly 3 types of salts. What are 3 types again? I told you salt is formed as a result of reaction between acid and base. Now what are the 3 types? I wrote here acidic salt. Acidic salt in the sense, whenever we are adding an acid and a base, there will be strong and weak also. That means strong acids, weak acids. Strong bases, weak bases. Like that, if you take in the mixture of acid and base, if the acid is strong than the base, then the salt form will be having the nature of acidic, because the domination of acid is more, because acid is strong. Okay, now take in reverse. Take a strong base and take a weak acid. Now test. It also a salt, but it will be slightly basic. So the salt form here is basic salt, because the base is stronger than acid. Now when you prepare a reaction with both strong, equally strong, or both weak, that means taking a strong acid and a strong base, or weak acid, weak base. Either of them, if it is strong, we will be getting any of the above results. If both of them are weak or both of them are strong, there will be no domination of anybody, both are equal. Now it forms a neutral salt. So depending upon strength of acid and base, whichever is powerful, that type of salt will be obtained. If both are equal power, then we will get a neutral salt. And at the end of the lesson, you have the uses of acids, bases and salts in our daily life. Like acids, all the citrus fruits, we prepare pulihora, we prepare pickles, chutneys and all those things. Those are the uses of acids. Glass cleaners, soaps, detergents, those are the uses of bases. And salts, as we discussed, even the table salt. Okay, table salt, commonly what we use in the food, those are some salts. So all of them are listed. Those are all daily items what we use. So now go through all these activities. The neutralization reaction is so very important, and also the types of acids, bases and neutral salts also. So just go through all these activities, try to answer the questions that are given along with the video. Anyhow, next day you will get answers that you know, but before getting the answers, try to answer the question. And also at the end of the lesson, in the improve your learning topic, you have some questions listed in the textbook. Answer them on your own. prepare all the activities very well and stay home, stay safe. Thank you.